Welcome to my channel. If you are new to this channel, try to subscribe, like and share. Today we want to talk on binary operations, and out of all the binary operations properties, I would like us to check into two or look on two, that is identity and inverse. Now, why did I put them together? Because there is no way you want to find, if you want to find an inverse on binary operations, automatically you have to get your identity first. Now, in binary operations, we use letter E. Letter E represents our identity. It represents our identity in binary operations. That means E is going to be the element of R. Now, what does that mean? Let's continue about it. Actually, the formula for identity under binary operations, if A, assuming if A is one of the members or elements of a set R, they give us a set R here. And you see, they say A, B is the element of R. Now, if A is the element of R, the formula for binary, in binary operation, the formula for identity will be A asterisk E, because E is the identity, is constant. The E identity is constant. It's our identity. A asterisk E equals to identity asterisk A equals to A. That's the formula for identity in binary operations. A, if A, as you can see, A is one of the elements of set R. Under the closed binary operation of asterisk, one of the symbols of binary operation is asterisk. A asterisk E, which that E stands for our identity and is constant, equals to E, which is our identity, asterisk A, you will use the same letter, equals to A. Now, don't let us forget, anytime you are asked to look for identity, bring out this formula first. Now, next thing is to do. After you've done that, and they said let asterisk be an operation, a set of R of real number defined by A asterisk B. Now, when you look at what they give us A asterisk B. That means A, if you follow what is here, A asterisk, you cannot change this B changes to E that you see here. A asterisk E equals to E asterisk A equals to A, as you can see now. And what does that mean? That means, don't forget to say A asterisk E equals to A plus B. They give us in form of A plus B. That means A plus E. It will change to, instead of writing B now, it will change to E. A plus E equals to A. Now, we just need this. This is all we need. A plus E equals to A. Let me say it again. Since our formula is this, A asterisk E equals to E asterisk A equals to A equals to A. Are you getting this? I just need this equals to A. That's what I need. But I have to follow what they give us. They give us divide by this. A asterisk B equals to A plus B. That means instead of I'll follow plus, they didn't follow plus. That's why I change this to A plus C. Don't forget, instead of writing B, you change this to E. But the formula of identity followed by E. A plus E, everything equals to A. And don't forget, I'm looking for identity, and identity is E. That means I'm making E isolate the formula. That means E equals to, I'll bring this A to here. A minus A. So that means identity equals to 0. The identity here is equals to 0, which is our E. Do not forget identity here. Another name for identity, we can also call it neutral. You can call it neutral. You can say find the neutral. When you hear find the neutral, it also means the same thing to be identity. Let's take like one more or two more examples under the identity before we now go to invert. Now we are still under the identity. I would like us to check this example again. I think by doing this and one more, we should be able to get everything about under identity. They said an operations. This is a sign for binary operation, one of the signs for binary operations. Downside of the triangle, the symbol of binary operations, is defined on the set R of real numbers. This is what they give us, the definitions for this binary operation. Equals to AB all over 3. For all the elements A, B, A is the element, B is the element of R, this set of R. Like the way we were doing in our set operation, we give us like this, set of R, A, comma, B. So that's what they are saying. That's what they are saying. Now, they find the identity element. I've told us earlier that when we are looking for the identity element, you can write out the formula. The formula for identity is A asterisk E equals to E asterisk A equals to A. Now you just need to just pick this one. This one equals to the A asterisk E, is our identity, equals to A. Now, after you have done that, now compare this with this. Because this is what they gave us in their questions to follow. Now, that means I've told us earlier that since E is our identity, which is constant, so that means we are changing this, and we have to follow what we see here. Just follow what you see here. So that means I'm changing this B to E. I'm changing this B to E. So what am I going to have like that? I'm going to have A, another opinion symbol, E equals to A, E equals to 3. A, E equals to 3. That means A, E all over 3 equals to A. Equals to A. According to our formula. Our formula says A asterisk E equals to E asterisk A. Everything equals to A. That means if you pick this thing, it's also equals to. That means A asterisk E equals to A. A asterisk E equals to A. That's why after I've written this, A, E all over 3 equals to A, because I have to follow the patterns for identity. Everything now equals to A. Now, let's now find it. After you have done that, when I say A, E over 3 equals to A, what am I looking for? I'm looking for E, which is our neutral or identity. So I'll cross multiply, as you know. That means if I cross multiply, that's A, E equals to 3 times A, 3A. But don't forget, I'm looking for E. I'm looking for E. That means divide both sides by coefficient of E, which is A. A over A. A cancel A. So that means identity equals to A cancel A here. Our identity equals to 3. Our identity equals to 3. Equals to 3. So let's take one. Now let's look at this one again under the identity. Now they said the operation asterisk on the set of real numbers is divided by x asterisk y, and that x asterisk y, let's bring out these things. Divide on this. Divide on this. That means the x asterisk y equals to 2x plus 2y minus 1 all over 2. For all the members is x, y, and the element of R. Find it, like I told you, they say find the neutral. The neutral is also called identity. Find the neutral element, which is our E in R under the operation of this asterisk. Now, like I told us, don't let us forget the formula. Since we are given x here, so it's going to be x asterisk E, which is our identity, equals to E asterisk x equals what? X. They say the same patterns of A, asterisk E equals to E asterisk A, everything equals to A. Since A was given in the other examples. Now they start this one with X. So that's why I changed the story to X. X asterisk E equals to E asterisk X equals to X. Don't forget our X is our neutral or identity. Now, what are we going to do? It told us follow the pattern that is here. So that means anywhere I see Y, I'll put identity, which is E from this. That means my X asterisk E equals to 2, I see X, write it, plus, now I see Y here, I'll put my identity, which is E, I'm following, that is, I'll put in place of Y, which is E minus 1, all over 2, everything equals to what? Equals to X. Should not forget, anywhere I see X is E, but don't forget, according to the formula, everything is equals to X. Now that means I just need this. So what I need now is that 2x plus 2e minus 1 all over 2 all equals to x. So I can cross multiply, that is 2x plus 2e minus 1 equals to 2x if I cross multiply. So, but I'm looking for my identity, which is E. I want to make it a subject of formula. That means 2e equals to 2x. If I bring this one to the other side, it becomes minus 2x. If I bring minus 1 to the other side, it becomes plus 1. So that means I'm having 2e equals to, this one cancel this one, plus 2x cancel minus 2x equals to 1. So I'll divide this out by 2. All over 2, all over 2. That means my identity equals to 1 all over 2. That's all about the identity. So about the identity.